Hi guys, this is me again, and hopefully my videos are being helpful in just keeping you up to date with what you should learn. And this is the identity sheet part of it again, nicely with what branches out of it. But I did put on the blog a suggestion that everyone should make something called personalized identity sheet. So this is from last year. You can see how neat and nice is this identity sheet. It's personalized. It goes in your notebook. You can put it in the folder in your notebook. It goes into your binder if you want. It's handwritten because I know everybody likes to see their own handwriting. And it's numbered. That's what's nice about it. So if you guys see I1, identity 1, I2, I3, I4, and so on. So as we're doing the practice problems, when I tell you I'm using identity 12, right away you know which one I'm talking about. This is like a common language for all of us. So this is a strongly recommended. I put this sample on the blog. You can basically copy it down if you want. You can rearrange it, but as long as you keep the same numbers, because when I say again, all videos, and even if we were in class, I'm gonna say I'm using identity 12. Right away, you guys should know that it's secant squared equals 1 plus tan squared. So this is my suggestion. We'll go back and forth to this as needed. But today's day 3 of section 5.1 is to just go over a couple sample problems. Not sure if I did go over these, but just to make sure I addressed everything. So example 4, cosine of negative x minus cosine x equals 0. And sorry, my son is playing Fortnite, so you're going to see all those notifications, annoying ones, because this is his iPad, but it's been helpful. Anyways, you can ignore all the factors of distraction. So cosine of negative x minus cosine x equals 0. Prove that. Why is that true? If we look at cosine of negative x, if you guys remember, we said memorize 2 are even, everything else is odd. Cosine and secant are even. So cosine of negative x is the same as cosine x. And you can see, guys, how I put identity 20. So if you can go back to identity 20, you can see that it's the even odd identity. This is where this personalized one comes in handy. Cosine of negative x equals cosine x. So I did use that, identity 20. And that's why when you say cosine of negative x, which is the same as cosine x minus cosine x, of course, it's going to equal to 0. Now, the last example, which is example 5, it looks a lot more messy than example 4. Let's break it down together. Secant squared is 1 over cosine squared, because secant is 1 over cosine, and cosecant is 1 over sine. But they're both squared. Why? Because the original ones are squared. And even if you ask me, why didn't you square the 1? Actually, the 1 is squared, but 1 squared is 1. So this is where 1 over cosine squared come from, 1 over sine squared. And also, you do the same thing for the denominator. And if you notice, you might say, oh, it's the same up and down. True, but at the same time, on the numerator, you're adding, on the denominator, you're multiplying. That's why you can't go and cross everything. And also notice that the cosecant on the bottom is not squared, and that's why the sine is not squared right here. So what do we do next? And I repeat over and over, there's no way I tell you do this next and do that next. It comes with practice. But I see a cosine squared, so I want to make a common denominator. So I'm adding 2 fractions. I need a common denominator. The common denominator here is not as easy as a 2 and 3, and you're trying to find a common denominator, but it's cosine squared and sine squared. But it's the same concept. So you multiply the first by the second, and you multiply the second by the first. What you do on the bottom, you do on top. So sine squared multiplied by 1 is sine squared, plus cosine squared multiplied by 1 is cosine squared. Now you see the famous identity that you wish to build. Why? Because it equals 1. So this, according to identity number 9, equals to 1. And the common denominator is sine squared multiplied by cosine squared. The denominator, you don't need a common denominator on the bottom. Why? Because you're multiplying. And the rule says when you multiply straight across. So 1 multiplied by 1 is 1. Cosine squared multiplied by sine is cosine squared multiplied by sine. Now let's see how this will look a little bit more simple. So the top, the highlighted one, is a 1 over this denominator. I wrote it down. And keep, change, flip, because you're dividing two fractions. This is when we use keep, change, flip. I can't use it from here. I can't do keep, change, flip from here because those are two fractions. Until I get a single fraction on top, a single fraction on the bottom, I cannot apply keep, change, flip. So 1 over sine squared multiplied by cosine squared multiplied by the flip of that. So cosine squared multiplied by sine over 1. Keep, change, flip again. 1, 1 cancel out. Cosine squared cancel out. And you're left with 1 over sine. How do I know 1 over sine? Because sine over sine is squared. And let me write this down. So sine x divided by cosine squared of x. Divided by sine squared, as if you had t over t squared. That reduces to 1 over t. So this reduces to 1 over sine. So this is where I got 1 over sine from, and 1 over sine is cosecant. I just put right here a few reminders about basic rules. When we add, we cannot just simplify across. So I can't say 2 plus a 3 over 6 is okay. Let me simplify the 2 and the 6 and then that's it. No, that's not true. Why did I put that? Because I can't go, the first step that students would do, they would say, okay, let me get rid of these. And I'm sure most of you thought about that. We cannot. Why? Because there's that plus in between. So this is where this comes from, this basic rule. But if you're multiplying, yes, you can simplify across and you get the same answer. And we used that. Let me tell you where we used it. We used it right here. When we multiplied, we were able to simplify across. So those are two basic rules that I really needed to review with you guys. And I put up in the corner a quick example of how to make a common denominator when you have numbers. So if you have 3 and 5, you multiply the 3 by 5 and the 5 by 3. Similarly to what we've done here, we had cosine squared and sine squared. We multiply the cosine squared by sine squared and the sine squared by cosine squared. So same basic rules, but we're applying them to harder functions. So you're not applying them to numbers, but you're applying them to trig functions. And I also gave you an example of how we multiply fractions. When we multiply fraction, we multiply numerator with numerator, denominator with denominator. So those are the two sample problems that will help you do the homework, which I posted on the blog. It's page 410 and continues on page 411, number 23 through 32. Again, feel free to text me any questions you have. Thank you and good night.